Wow. Okay. Hello. Hello. It's Friday night in London. It's really horrible. It's wet and rainy and very unpleasant. So I thought that instead of going outside, I would make a start on uh, something new. Um, and I don't really have a plan of how this is going to go, but I thought that I would share it as I worked on it. And I don't know if that's going to work. It might be a disaster. This might be the only time I ever do this. I never streamed any programming stuff before, so this could turn out to not be a very good idea. But I thought I'd see what happened if I did it. And maybe it'll be fun. Or maybe it'll be amusing because I will go completely wrong when I'm trying to write some code. So let's see. Okay, so I'll get started. The thing that I am going to take a look at today is to start writing a WebAssembly interpreter in Ruby. I don't really know how to do that, but that's why it's interesting. So I thought I would, I thought I'd give that a go. So that's what I'm going to try and do now. I sort of had a few reasons for wanting to do that, and I thought I would just very briefly explain those reasons before I get stuck into it. The first reason is that, well, like my motivation really is just to sort of have fun. I don't intend this to be any kind of serious project. It's just something that I want to do, to see what happens. So I don't have any high-minded goals for it really. Secondarily, I wanted to have a go at sort of demystifying WebAssembly. I have never really used WebAssembly in anger. I don't really know very much about it. I don't really know how it works. And it seems like implementing an interpreter for it might be a fun way of teaching myself, and I suppose optionally you, if I end up streaming the whole thing, how it works and how the bits fit together and what the idea of it is and all that kind of thing. So that's something. And a third piece of the motivation is just to sort of share how I go about doing it. And I've got a couple of specific things in mind there. But I suppose more broadly, that's the reason for bothering to record it, right? Is I could have fun and I could demystify WebAssembly just by doing it in private. So I thought it might be fun to just try and kind of share it a bit as well. So those are my reasons for doing it. Before I get started, I also had a few principles that I'd written down in an Apple Note, and I thought I would reiterate them here to kind of try and remind myself of like, how do I want to do this? Like, there are so many different ways to do something like this. So I've decided that firstly, it's got to be fun over function. Like the point of me doing this is to enjoy it. And so what I'm going to try and do is get some subset of WebAssembly working in Ruby. But I'm not really that worried about it, like working, certainly not being a complete implementation or being, a usable implementation for any practical purposes. Like the reason I'm doing this is just to have some fun. I'm really just saying this to myself to remind myself that it's okay to just write some code to enjoy it. So that's the first reason. Second, or the second principle is that to whatever extent I do manage to get any of the semantics of WebAssembly implemented, I'd sort of like to focus on getting those semantics correct, even at the cost of performance. I mean, especially at the cost of performance. I think it's for something like this that's supposed to be fun and sort of educational for me, I'm much more interested in like getting it right than, coming up with a way of doing it that's going to be super efficient. Because if you want to execute WebAssembly efficiently, the way to do that is not interpret it with Ruby. So yeah, I'm going to try and stick to that principle and not worry too much about whether what I'm doing is like efficient or not. I just want to make sure I get it right. And I suppose in the same vein, I want to try and write code for my own purposes that's sort of as clear as possible, and not get sucked into writing clever code, and whether that means fast or, I mean, really, like normally when I'm writing production code or I'm writing code at work, I'll be quite focused on like maintainability and cost of change and the design of the code and all of that kind of stuff. But because I'm just doing this for fun and sort of educational purposes, I sort of want to focus on trying to make the code as clear as possible, even if it means that it's not particularly well designed. Like, I want to be able to understand it when I look back at it, even if that means that it's harder to maintain or whatever. So I'm going to kind of prioritize clarity over the sort of cleverness and maintainability and OO design and all that kind of stuff. I just sort of want to power through and get a prototype working that I can understand, that helps me to kind of feel like I've got a good grip on the semantics of WebAssembly, basically. I want to do it in pure Ruby. I don't think that there are any, or at least I couldn't, with a cursory search, I couldn't see anyone who'd done a pure Ruby implementation of a WebAssembly interpreter. So like, that's a fun thing, and it's very, very, very mildly novel. It's not a thing I can already go and look at. So yeah, I quite like the idea of having a partial WebAssembly implementation that is just written in Ruby, that doesn't require, you don't need to install any other, it's not, it's not an interface to some kind of native library that you have to install or anything. It's just like, just going to do it in Ruby. And I guess that goes back to sort of, not worrying about speed or cleverness. I'm just going to kind of try and grind through it in Ruby, just to keep it as simple as possible. And on the same note, I suppose, I want to see if I can do this without bringing in any third-party dependencies. It feels like that should be possible. I mean, I do like the idea of being able to make an implementation of a WebAssembly interpreter that you can install, and it's completely dependency-free, and there's no native code involved. It's all just written in Ruby. I think it's probably a little bit ambitious at this stage to be thinking about having an implementation that you could install, because I think it's incredibly unlikely I'm going to get that far. In fact, I might just work on it for an hour or two tonight and then get bored of it and never touch it again. But this is kind of the high-minded principle I'm going for, right? Is like, is it possible to write something like this that doesn't have any dependencies? So that's it. That's, sorry for the long-winded intro, but like that's basically it. That's what I'm gonna do. I've got my terminal. I'm gonna try and write some code, and hopefully it's gonna work. If it doesn't work, then that's a bit embarrassing, isn't it? So I'm going to, what do I want to do? I'm gonna open a browser, I think. I don't want it to be too much like lead up. I want to start writing code as soon as possible, but I did want to just say a little bit about like what WebAssembly is. And I don't really know this, but I know a little bit. So WebAssembly is, basically is a programming language. It is a low-level programming language, very low-level, like assembly code, but it's designed to run, well, the semantics of WebAssembly are defined with respect to this sort of abstract machine, so like a little stack-based VM, and that has been designed specifically to map well onto like the actual instruction sets of real CPUs. Initially, this was intended to be targeted at the browser specifically, which is why it's got web in the name. But there are now plenty of non-browser implementations of WebAssembly runtimes. So yeah, I guess this basically says that it's a binary instruction format for a stack-based virtual machine. But that's a fancy way of saying a programming language, right? What's sort of interesting about it is that it's got a sort of a plain text format and a binary format. So if you want to write your WebAssembly program, you can write it in a text file, and there's a concrete syntax for it, or you can write it as a sequence of bytes into a file. Humans don't do that, but it's sort of comparable to assembly code and machine code, but the programming language is called WebAssembly, so that's a bit confusing. I don't think there's any like interesting distinction between those two formats. I think it's just two different ways of writing a sequence of instructions, and one of them is sort of human readable, human editable, and the other one's more compact and takes less time to send over the network and stuff like that. What else is interesting about WebAssembly? A few things. One of them is that it's, maybe when you think about assembly code, you think about the sort of linear sequence of instructions. As from what I can tell, so this is where I've basically said everything I know about WebAssembly now, so I'm starting to venture into the territory of like stuff I don't actually know about. But my understanding is that WebAssembly is, rather than being like a linear sequence of instructions, it's a sort of tree. So you sort of have an abstract syntax tree. So in this plain text file or in this binary format, it's not just a big long list of instructions with labels in it. It's actually an AST. So it's sort of block structured. And you can see now I'm getting very vague because I've never really written any. But I have a slight sense of like it being at the control flow level, very slightly higher level than something like actual x86 assembly or something. So it's already got some notion of like block structure in it. The other thing that's interesting about it, and really this is getting onto like why I decided I was interested in this, is that it's got this really quite formal specification, which I suppose isn't that unusual. But like you would expect for a specification. Sorry about there's a flash of math jacks there. It's got this big long specification that's very detailed and very sort of mathematical. And I find that quite appealing. Like I found, just skimming through this, I found a lot of it quite, not necessarily easy to read, but like it's satisfyingly unambiguous. So I quite like the fact that like it feels like probably everything that you need to know is in here somewhere in a sort of unambiguous way. So I find this quite appealing. I mean, what I'm worried about is how much of it there is. It's certainly very intimidating how much stuff there is here. But the stuff that is here, I sort of tried to read some of it and I sort of figured out what it meant. So it makes having this big unambiguous specification of the language kind of makes me think, oh, right, this is something that I could probably understand or implement. So that's good. I was really heartened to see this sort of comprehensive specification of the language. The other thing, the most concrete thing that I was interested in is that on GitHub, WebAssembly, there's a repo where all of this lives. So that spec we were just looking at is in this GitHub repo. But what else is in this GitHub repo is that there's this reference interpreter. So the spec repo actually comes with this implementation of a WebAssembly interpreter. In fact, why don't I what's it called? Spec. I'll clone this. So this it's written in OCaml, which again is the thing that I really like. It's a language that I'm familiar with, or at least I was like 20 years ago. I used it a lot. Haven't used it much in the last decade and change. But anyway, that's not important. What's important is the spec comes with this reference implementation. So that's cool. People, as far as I know, don't actually use this. And I assume the reason they don't use it is because it's, some of the stuff I said before. Like, I think this has been implemented sort of for the purposes of clarity and correctness rather than to be super performant or whatever. Oh, God, this is taking forever. Let's do a shallow clone. Okay. So it's interesting that this exists. Let's have a look at it. I think I can just make this. Okay. So this you can call this with a with an actual piece of source code, but you can also just get a REPL. And once you've got a REPL, where is it? MDN WebAssembly docs. I'm just trying to find text format. I'm just looking for some kind of example code. Yeah, I remember reading in this documentation there was this thing that's got some code. So I think, look, I can just press this. So I think if I, right. So I suppose this is like, I should have shown this before really, like here's a bit of WebAssembly code. This is defining something called a module, which I think is just a collection of functions. I don't really know, but you can define a module and then you can see here it's defining a function inside that module. That function's got a parameter called LHS, a parameter called RHS, so that's left-hand side and right-hand side, and then it's got some instructions inside that get the left-hand side and the right-hand side and then add them together. And then that function gets exported under a given name. And so you can see in the WASM interpreter, I can kind of evaluate that module definition. And then I think probably I can run that function. I'm not entirely sure. Invoke add, oh God, i32.const to i32.const 3, 5. Yeah. Okay. So that's about the limit of my ability to write WebAssembly code. So I'm not going to try anything else. But like, you can see this interpreter exists, and that's cool. But the thing that's really interesting about this, and this is really what like gave me the idea that I wanted to have a go at this myself, is that in addition to the reference interpreter, there's this test directory, and inside test/core. It's got all of these files that are basically acceptance tests for the implementation. This directory contains tests for the core WebAssembly semantics. So I mean, let's just pick one of these. I don't know, switch. So these are files that have got. So this is like plain text format as before, and they've got loads of like function definitions in them, and then further down they've got all these assertions, and there's in the make file, you can, if you type make test, I mean I suppose I can do that, what it'll do is go and try to run all of these acceptance tests essentially to check that the implementation of WebAssembly is sort of compliant with the specification. So all of these files are kind of executable specifications of WebAssembly, which is really interesting and immediately to me suggests the question, how far can you get if you're a person who doesn't really know anything at all about WebAssembly? How far can you get implementing an interpreter for WebAssembly just sort of based on the information that's that's encoded in all of these acceptance tests? And I'm prepared to accept that the answer is not very far. But nonetheless, it's kind of cool that these all exist. Yeah, I mean, there's a bit of a problem, which is that they're all quite complex. So, I mean, I'll stop this running, but you get the idea. That's, that's running through all of those. These are all pretty complex. So this hasn't really been designed to make it easy to use as part of a sort of outside-in acceptance test-driven development of a WebAssembly runtime. But maybe I can do it. Maybe I can still do it, even if that's not how you're supposed to. Anyway, I don't know. I'm going to give it a go. So let's see. I'm trying to think about how to start. How do I want to start? Well, I did have a quick look through this before. So I do have a kind of vague sense of what there is in here. I gravitated immediately towards these files called i32 and i64 because these suggest to me that these are for the 32-bit and 64-bit integers, which is probably one of the simplest things that they have in the language. So I think I probably want to start in this general area. I can see up here that there are floats as well, but that's a little bit more frightening. So looking at these files, you can see they're not too forbidding, although like this file, for example, it's still got a lot going on in it. It's got, function definitions and function parameters and, actual operations on those parameters. And here, function calls with arguments and stuff like that. So that's like not too daunting, but still feels a little bit daunting. So that, yeah, there's this one in literals that looks a little bit more approachable. So this like i32 looks like it's sort of testing 32-bit operations essentially, whereas in literals, like just looks like it's literally testing, like testing literals. So I mean, if we have a look at one of these, we can see here there's this function called i32.test, and it just returns this 32-bit number hex. Bad dude. And then there's an assertion down here that asserts that, so this is assert return. In fact, let me also pull up, because there's something relevant here. These WAST files aren't actually WebAssembly source files. So this, like, if you were thinking like, well, where's the definition of this assert return function? The answer is it's not defined anywhere because it's actually part of the syntax of this file. So if I find, so here I'm looking at the reference interpreter here, and this WAST format is designed specifically for, so it says, in order to be able to check and run modules for testing purposes, the S expression format is interpreted as a very simple notion of script with commands as followed. So this WAST file is like a script file. So with reference to the actual abstract syntax of WebAssembly, which is further up in this file, it says a script is 0 or more commands, and a command can be either a module or an action or an assertion. And if here assertion, it says, here we go, assert return. Assert action has expected results. So you can see in this case, one of the actions is invoke, which is calling a function. So here it says assert return. So assert that the result of invoking i32 test is the value of this expression, which is the constant 195940365. So this is sort of almost testing nothing, although what it is testing is that your implementation's ability to convert a hex number into decimal works properly. So this is like to me, this seems like a fairly minimal place to start in terms of the semantics, because there's not really any, oh look, there's one addition in here, there's an i64.add, but everything else in this, there's an add here as well, but all the rest of them are just checking that the interpretation of some constant is equal to a different representation of the same value. So that feels approachable. I think if I hadn't been able to find this, I would have given up on this idea. But the fact that there are these files that literally, no pun intended, just test effectively the syntax of literals is kind of quite appealing. And finally, I saw there was also this tokens.wast, which just appears to be a load of gibberish. Like, this doesn't have any, well, it's got these assert malformed, which I'm just going to ignore for now. But essentially, it's just got all of these, it's just got a bunch of different syntax in, which I think is sort of intended to stress test the parser. So maybe this would be a good place to start, because there's not, if I ignore these, at some point I'll want to get this assert malformed things working. But you can see that the errors here are things like unknown operator, unknown label. These aren't parsing errors. These are like verification errors. You know, once you've parsed the code, you're going to check it to make sure that, you know, or at least at the very least that it sort of makes syntactic sense. At this point, I'd really like to be able to just, in terms of trying to get this int literals thing working, I think I'd like to be able to just parse this whole file, like just as an S expression, essentially, like, and what I'm talking about there is just a string that's got sort of nested brackets in it. So it consists of atoms, so sort of individual values, if you like, and then lists with parentheses around them. So I can sort of see by looking at this that if I want to try and get something working as quickly as possible, which is my goal here, I'm going to stop just talking in a minute and writing code, but just thinking out loud, I would really like to get to the point where I'm actually like, where my teeth are getting sunk into this, right? Where I'm actually getting a chance to read this bad dude and check that it is indeed this decimal value. And to be able to do that, I have to have some kind of parser that is able to read this. And I think if I can get away with just treating this as a sort of, as an S expression, so that all I understand is that this is a list and it's got atoms and other lists inside it, even though there's a lot more, you know, there's like a proper grammar for this language, and I can, you know, there are certain places where you're allowed to say the export keyword or whatever. Like, I think I'm just going to sort of kick the can down the road a bit on that one and just focus on, like, can I actually get something working that doesn't really understand the I suppose the syntactic grammar of the language, but isn't just treating this as a big soup of bytes in a file. It's actually able to treat it as like structured data. Yeah, so the reason I'm saying all that is because I think this tokens.wast file is probably a good place to start, because if I can, you know, it's sort of annoying that there aren't any assertions other than if I read this, if I'm able to read this in and then like look at the resulting S expression and convince myself that it's correct, then that means that it's passing. It would obviously be better if I had a sort of, I don't know, a JSON file or something that contained like the canonical S expression for this, because I can see there's lots of in these comments saying tokens can be delimited by parentheses, for example. So this is going to be checking that I can stop reading when I reach this close bracket, and I can, you know, read a 0 there and then stop when I reach the opening bracket. And things like here, tokens can be delimited by comments. Like, this is a little bit fiddly. So yeah, it would be nice if I had a sort of a reference for what this is supposed to look like when it's been correctly parsed, but I don't have that. So for the purposes of today, I think I'm just going to sort of eyeball it. So this is an example of just how loosey-goosey I intend to be with this. Anyway, okay, let's actually start doing something then. Make a git repo. I'll make a, I don't know what's going to go in this file, wasm.rb. There we go. We've got a commit already. Add empty wasm interpreter. Great. Okay. Done. See you next week. All right. So what am I going to try to do now? All right, so I know that I've got this file in the file system. In fact, it's in wasm spec test core tokens.wast. Okay, so that's where that file is. So what do I want to be able to do? What I really want to be able to do is sort of say S expression is expression parser dot new dot parse. If I read from argv, then I can just give that file on the command line. So if I was able to parse that S expression and then pretty print it, then that would put me in a situation where I was able to eyeball whether it was doing the right thing. So let's say Ruby wasm.rb and then that path. Let's do it like this. Test core tokens.wast. Okay. So I think this is the shape of it. This is what I want to do. But now I'm going to have to start implementing stuff, aren't I? And I guess I should stop and say, I started thinking about like, how do I want to TDD this? You know, do I want to use RSpec, or do I want to use Minitest, or do I want to use test unit, or want to use Cucumber, or like, and I spent 10 minutes thinking about it, and then I got sick of thinking about it and just decided that I'm just going to see how far I can get, just like winging stuff into a single file and not get distracted by choice of testing framework and stuff like that. So let's see how that works out. I may well live to regret that. Well, anyway, so the point is uninitialized constant S expression parser. So I realize I don't really have any kind of test here, but like, this is my test, all right? trying to use this S expression parser. I'm just thinking, if I start writing a parser down here, this is going to get quite long, and I'm going to have to put this code underneath it. I'll tell you what, I'm going to do this. So that I can put the code in this order. So I'm going to, all I'm doing, the only reason I'm doing this is so that I can have like the code that's actually executed at the top of the file, because that's sort of where my brain wants it to be for some reason. And then I can start building this parser from the top down, but then the main code is still going to be at the top, and then that just gets run at the end. So I think that's still, okay, undefined method parse. Okay, right. So I'm kind of getting somewhere. String. So for this to work, I'm going to have to remember that string, and for that to work, I'm going to need a string. So the way I need to practice thinking out loud. What I'm thinking here is that I'm going to want this parser to hold on to a string that is the whole source file that we're trying to parse. Again, there's a temptation here to disappear down a rabbit hole and sort of treat the file as a stream of bytes or a stream of characters, and then build a tokenizer that turns that stream of characters into a stream of tokens, and then build a parser on top of that. That would be my sort of go-to strategy for something like this. But something that I thought but didn't say explicitly is that because this is just an S expression, it's so syntactically simple, or rather I'm sort of anticipating that the lexical grammar of what constitutes individual tokens is going to be so simple, that I think I can probably get away with smushing all of this into a single thing. Like my gut feeling right now is that it would be overkill to write a streaming tokenizer and a streaming parser and stuff just to spit out an S expression from the other end. I think I can probably just grind through the string and build nested arrays with strings inside them, all in one pass. So let's see if that's true. But in order to do that, I'm going to need to hold on to a string that is the sort of the fragment of the input that we haven't parsed yet. So initially that's going to be all of it. And then what I'm thinking is that this piece of state that lives inside the S expression parser is we're just gonna chew characters off the front of it and sort of take successive suffixes of that string until we get the empty string, and then we're done parsing it. And I could just as well have a cursor or something, an index into the string. But I think I can probably get away with this. Again, I should explain my thinking. The reason I think I can get away with that is that regular expression matches in Ruby make it very easy for you to get the section of the string that comes after the regular expression match. So I'm sort of thinking, as I'm chewing through this string, if I'm using regular expressions to match stuff off the beginning of it, I can then just say, well, what's the post match, which is the rest of that string, and then use that to sort of update the part of the string I haven't chewed through yet. Which is a very long-winded way of saying I'm going to hold on to the string. So I'm going to hold on to the string. Then what am I going to do? I mean, there's no way that I'm going to be able to get any useful... oh, well, I mean, this does return something. So it's dutifully pretty printing this massive string that is the whole file. So there's no exception being thrown, but this is definitely not the behavior that I want, because I'm not getting... Well, arguably I am getting an S expression back, but it's not the one I wanted. So what I'm going to do, I think, is start thinking about, maybe with reference to this, start thinking about like what are some of the simplest... Start building up from simple cases until we get to the point where we can sort of start to deal with something like this that's multi-line, and has got white space, and has got comments, and has got all these sort of slightly gnarly interactions with semicolons, and I can see there's some rules about spaces down here as well. So let's give that a go. The way I'm going to do that, again, just for now, resisting the temptation to sort of bust out the testing framework. In fact, those pluses in the gutter are reminding me that I should probably make a commit at this point. So, I mean, this really does nothing. Sort of add skeleton, S expression parser, and run it. Okay, that's better. So what I was thinking was I can do some sort of, if I was going to parse some S expression, it's going to parse some string. So it'd say like input equals, what do I want to do here? Yeah, I suppose that's fine. If the input was just hello, I would expect the result of parsing that to just be, I'm just going to use strings here. So like that's a single atom in sort of S expression parlance. And so I would expect to be able to just parse that input. And then the actual is going to be S expression parser.new.parse input. And then I'll say raise unless actual equals expected. So that's effectively a little unit test. Let's run that. Okay, so that didn't raise an exception. In fact, maybe I should be able to just run this. Yeah, actually, that would be helpful. So I'm going to change this so that it only does this unless argv is empty. So what that means is if I do provide an argument, argv is the array of arguments that are passed on the command line. So if I do provide one, it's going to do that. But for this sort of unit testing, I can just run it, and if it successfully executes without raising any exceptions, then that means everything's working fine. So yeah, sort of amusingly, yeah, because at the moment this parse method is just returning the original string, that one works fine. And I suppose that's a commit. Let's add this bit. So this is test that S expression parser can parse a single atom. Okay, which I can. And then I've got the rest of what I did, which is only parse command line input when file name. Because argaf will, if you don't provide any arguments, it will just give you standard input. So it's very convenient. And I mean, I imagine at some point I'm going to want to just make this unconditional. But right now, it's actually kind of useful to be able to just run this without any input so that I can kind of trigger those ersatz unit tests that I've written. So, okay. So yes, I was adding in some more stuff here. So what if I put some brackets in like that? I would expect the output to now be an array containing, so this is like a list containing the single atom hello. These two lines can stay the same. So hopefully what I'm expecting to see here is, well, I'm expecting to see an exception being raised. That's actually not super useful. Let's say raise actual.inspect, because I actually want to see like, well, what did I get? But what I'm expecting to get is a single string, a single atom containing those parentheses. And that's not what I wanted. What I wanted was an array. So we're going to have to do some actual parsing now. So let's start thinking about what wants to happen here. I'm just going to start sketching this out, imagining that I have some helper functions that I haven't written yet. So what I want to say is, I'm about to try and parse an expression, right? So what I want to say is that if I can read, I mentioned regular expressions before, so I think I'm gonna just assume that I want these things to be regular expressions. So if I can read this regular expression, is there a way that I can? Is there some kind of? I'm just thinking about whether I can get away with using strings even though I want to treat them as regular expressions. Is there like a kernel regexp function? Is that a thing? Like, can I say no? I was hoping there might be, you know, there are all those sort of nice sort of coercion methods that, you know, do that kind of business, and then if you give it something that's already an integer, you just get an integer. I was sort of wondering whether I could, you know, whether I could get away with having something that sort of converts things, but I don't know of a good thing that does that. Anyway, it doesn't matter. I'll just write regular expressions. That's fine. So if I can read an opening parenthesis, then, you know, else, well, I suppose, again, assuming I wasn't really doing this before. Before we were relying on the return, accidentally relying on the return value of this. I'm going to need some kind of helper. I'm going to need some kind of helper that can do this, right? That can read the opening parenthesis and then do something and then read the closing parenthesis, right? So I'm going to need this sort of read function. So if I've got that, then just sort of for tidiness and symmetry, then here I can just say like read anything, one or more of anything, and that's going to return, in this case, the entire string. So what's this actually going to look like here? I think what this is going to look like is, well, what I need to do is call this piece of code again. So I need to pull this out because I don't want that self.string equals to happen again. So I need some kind of parse expression here that contains all that code I just wrote that we call here, because this needs to call itself recursively here in order to parse what is inside those square brackets. Sorry, the parentheses. And then it needs to return an array with whatever that is in it. So I guess it's like expressions is an empty array. And then here we say expressions. We just sort of concatenate that onto the end of the array, and then we return expressions here. I think that's right. So yeah. I mean, I'm realizing now that I didn't really need this recursive call, because, you know, this could just as well have been this read, but sort of inadvertently done more work than was necessary there, but that's fine. Okay, so let me try and implement these helpers. Can read pattern. I think that's just going to be, well, does something match the string? It's not quite pattern, it's pattern sort of anchored at the beginning. So if I can say, does the beginning of this string match? Because, you know, I don't just want to ask, is there a opening parenthesis somewhere in the string? I specifically want it to be at the beginning of the string, so I can just say, does it match? And then that read function is sort of similar to that, actually. Maybe I can share this code between them. So this is going to say match equals that, and then this returns a match data object. From which you can get all kinds of stuff. But I suppose all I care about is, oh yes, I mentioned this before. What I care about is postmatch. So returns the portion of the original string after the current match. So that means that I can do self.string equals match.postmatch. So what that's going to do is essentially advance the cursor through the string, if you like, but via the medium of just replacing the string with whatever appears after the match. Just because I'm a bit paranoid, because this can return nil, I think. Nil if there was no match. So because I'm a little bit nervous about that, I'm just going to do a sort of or raise couldn't match pattern in string. Just because it feels like this, if this ever returns nil, I desperately want to know about that. So yeah, okay. So I think, have I implemented it now? Syntax error. Oh, I think this is just this is operator precedence. I think maybe if I make this an or, that will go away. Yeah. Couldn't match dot plus in hello. Well, I wasn't expecting that. That's because I've invented a new syntax for regular expression literals that isn't real. Sorry about that. Okay, where is that? Line 5. Oh, interesting. All right. So why has that not worked? So I've sort of broken the... Oh, I know why. It's because this doesn't return anything. Okay. Well, let me just run that and check. But yeah, okay. So this needs to not only advance the cursor, but it also needs to... How do you do this on a match object? Match data object. So you can do entire match substring. That's a little bit gross. So it has to string. Returns the entire match string. Okay. So, yeah, I don't know how I managed to type out this complete thing without... And then, of course, I copied and pasted it down here, so that error propagated itself. Okay, so now that's complaining. Where is that going wrong? Line 9. Couldn't match. Oh, right. Okay. Yes. So this is... okay, sorry, I should think out loud. What's going on here is that it's correctly... So the test that's failing is this one. And I think what it's doing is it's successfully reading the opening parenthesis, and then it's reading all of the rest of this string. So this read any character is to... what's the right word? Liberal? Don't. You are not allowed to read a closing parenthesis there. That cannot be part of what you're reading. So this is now this line, when it calls parse expression, it's going to read up until this closing parenthesis, and then it's going to, this line here is going to actually read it. So this is what I was talking about with the lexical grammar being fairly simple, is that like this could easily become a total nightmare, but I think because this is just an S expression, I'm hoping that coordinating the contents of these various regular expressions is not gonna be difficult, and I'm not gonna regret it. So let's see. Okay, great, that's working. So what have I done there? So there was actually, yeah, there was this that I did. So this was something like include actual result in failure message. So I think that was all I did there. So this one is right. Okay, so I mean that's quite a lot of stuff, but this is basically add support for parsing lists. I have to add it first. That's how Git works. Okay, so I've got some basic stuff there. What's next? How far away from this are we? Obviously, we need to be able to do this. That seems like an obvious thing, an obvious step in the right direction. Why am I doing that? Okay, so this test has failed, and it's failed by doing kind of what we would expect, which is it's correctly returning an array, but that array contains a single string that says hello world, and that's not what we want. This space should be separating those. So I think what I want to do here, so this has got to happen when we're inside these parentheses, right? So when you're inside parens, now it's a list, and the code I've got at the moment can only parse a single item list that's just a single atom. But what I want to be able to do, at least at this point, is to be able to parse multiple atoms, or actually multiple expressions. I guess I'm already recursively calling parse expression at this point. So what I'm going to do is put a loop inside here and try and have it do this multiple times. Clearly this shouldn't be an infinite loop. I think what we want to do is say break if can read that close paren. So we sort of go around this loop as many times as we need to, and then this is sort of almost a precondition that says like, well, if you're about to try to parse an expression, but actually the next thing you're going to parse is going to be a closing paren, then break out of the loop. So I would expect this. I don't think this has broken the existing code that we have. In fact, I think this is going to be a no-op. I think that it's going to be exactly the same error. Okay, yeah. So this doesn't change anything, but this just sort of gets us in a situation where realistically we could actually do it. And what I mean by do it is make it so that this thing here, I'm actually going to pull this out. Let's call this parse atom. Oops. So that's just going to read one or more allowed characters. What we need to do is make it so that it can't include that white space is not acceptable. I'm just thinking about Git here. Let me just add that. Okay. Before I actually change anything. Just trying to think of what the right order of operations is here. I think I can just put a space in here, but then I think that's going to break it. Yeah. So now we're in this situation where it has successfully read hello, and now it doesn't know what to do with this. It's trying to read another. It's like, well, the next character isn't a closing parenthesis, so I can't finish my list. So I've got to try and read another atom, but I can't because there's white space here, and an atom can't contain white space. So I think I'm going to need to, let's just do skip white space here. If before we try to parse the next expression, which includes checking to see that we've hit the end of the list, if we kind of skip over any white space, then that's going to sort of fast forward us to either the closing parenthesis or the next atom. So let's do that. So I think that's just going to be read one or more spaces. I'm just thinking what happens if this fails. That's going to raise an exception. Okay. Well, I could just make this an asterisk. I think I'm going to say if can read. If it's possible for me to do this, then do it. So that's going to skip the white space. So I'm hoping what's going to happen is it's going to parse the first time around the loop, it's going to parse hello. Then the second time around the loop, this is actually going to do something, skip over that space character. And then we're going to parse world. And then the third time around the loop, we're going to hit this break if can read, close paren. Right, great. Okay, so that's working. There must be a commit there. I'll just say support. How did I word this before? Okay, add support for parsing multiple atoms in a list. Well, it's probably multiple expressions, actually. I should write a test to verify that, but my assumption is that I've done enough work now that I can do something like that and it'll just work. Let's see. By the way, I realize I'm not actually implementing WebAssembly yet. I'm very aware of that. Maybe I should have just installed an S expression parser gem. I'm starting to just had that moment of doubt where I'm like, hold on, why am I doing this? But you know, I've had that thought too late. But also that's why I wanted to have some principles, was so that I wasn't having to constantly sort of second guess what it was that I was trying to do. Okay. In fact, I'm just going to amend that previous commit because I think that belongs in there. Okay, so this is looking sort of convincing. So maybe now I could start nibbling away at, I haven't really referred to this yet, but maybe I could start nibbling away at things I can actually see in this file. Yeah, I mean, why don't I just take some of this? What do I want to do? Something like this. I think that's right. So the reason I'm pausing is I'm just thinking about, do I actually want this? Do I want this? This looks kind of gross. Do I want this in my file, or could I just stick it all on one line with some new line escapes in? I think actually, in the interest of compactness, I am just going to do that for now. I might live to regret this, but I thought I was going to like that more than I did. And I was also fretting a little bit about things like trailing new lines, and you know, I could have indented it, but then that's introducing more white space, and so I think so that it's fully under control, I'm gonna leave it like this, and see. Oh, there's a few people in the chat who I haven't said hello to. Hello, everyone. Hi, Nadia. Hi, Chris. Comments. Yeah, I think. Yeah. Maybe if I can parse this, then I'll do a version of it that's got the comment at the beginning. It'll be fun to see that work. How can I... actually don't know how to make it so that I can see the YouTube comments all the time, so that's a bit of a shame because it undermines the whole purpose of doing this live. Maybe I can... yeah, I'm suffering here from not understanding how anything works. Anyway, so what was I doing? I was doing this. What do I want this to look like? So it starts like this, and then there's this, and inside that there's a func, and then inside that there's another list, and inside that there's an op. So yeah, that's right. Thanks, Vim. So again, I'm just pausing and thinking, am I expecting this to work? Yes, I am, except for the new lines. I think there's nothing in here that I can't support yet, but the new lines are a worry. So I think it's going to barf. Yeah, it doesn't know what to do with that new line. So two problems. First problem is you can see that it has slurped that new line into this first atom, which is not right. And I know that I can fix that by just, again, restricting the lexical grammar of what is allowed to be in one of these atoms. Well, you're not allowed to have a new line in it. But now that's causing a different problem, which is after we have read that module string, now we've got this thing, which it doesn't know. It doesn't know this is white space, because at the moment white space is just a literal space character. and it doesn't know how to read it. So I'm really glad I put this raise in, because this is already making it way easier for me to see what the problem is. So I'm going to pat myself on the back for that instinct. So, oh yes, so now I just need to add that into what white space is. So so if we've got spaces or new lines, then slurp them in. That's fine. Oh, what's gone wrong? Oh, yeah, okay. I was so obsessed with my white space that I didn't read this to see what the other problem was, which was that it slurped in this. So this whole section is about tokens can be delimited by parentheses, but you can see at the moment I'm not treating this opening parenthesis as being a terminator of this atom. So it's just running all the way up to the end, and then it's finding a well, I guess it's stopping there actually, after it finds the closing bracket, and everything's all gone a bit wrong. It makes me realize that this is actually quite... Sorry, I'm getting a little bit distracted there. It makes me realize that this is the s-expression parser.parse is successfully returning, even though there's still some stuff in the string that hasn't been parsed, which is, I think, what's happening in this case. I think there's a closing parenthesis that's still left in that string, in that buffer. So this is actually a little bit misleading as an error. It's like, oh, I've successfully parsed it into this S expression, but it's not the one that you thought it was. Well, no, actually you haven't, because you haven't even completely consumed the input string. So I'm going to try not to get distracted, but that did distract me. So I think what I want to do is here, when we parse this string, like this is really this is the sort of imperative shell of this basically functional, well, modulo this read thing. In fact, that whole analogy wasn't working. Forget it. But the point is, this is the method that adapts, like ports and adapters styly. This is the thing that adapts the public API to the guts here, which are things like parsing expressions. So this does this job of assigning the instance variable, then it calls parse expression. And what I'm thinking now is that I also want to like check that the string is empty and then return the expression. So here I need to remember this expression. Here I could just say like raise unless expression empty or whatever, but actually I'm thinking the raise unless string empty. But actually I'm thinking a neat way to do this would be to just try to read the end of the input, because I've already got some code. The reason that, sorry, I'm thinking out loud. The reason I thought that is because I've already got something that raises a useful error message here that contains all the information that you could possibly want. So I think this is actually quite a nice way of doing it, to say that like, well, you parse an expression and then you've got to read the end of the input and then you can return the expression. And then the intent of doing this is to prove that the buffer is empty. And if the buffer is not empty, then this is going to raise an exception. So I'm getting a little bit ahead of myself here, but all I'm looking for is a more useful error message than this one I'm currently seeing. Okay, yeah, that's the one I was looking for. Couldn't match \z, which is the anchor for the end of the string. So couldn't find the end of the string in new line close parenthesis. Now, I think that is a more useful error than this, although that has now obscured the cause of the error, which is the fact that this open paren has got slurped into that atom. So I can fix that, because I can just say, well, atoms cannot include closing or opening parentheses or spaces or new lines. So I think this is going to work now. Yeah. But I actually did quite a lot of faffing about there, didn't I? So I'd better... let me see. What did I do? well, this isn't necessarily the right order to do this in, but I definitely did this. Like, this is a nice self-contained change. Check that entire string was consumed by S expression parser. Parse. Okay. So that was useful. So, yeah. Okay, so we're actually, this makes me realize we're actually testing two separate things here. You know, there were two unsupported, I didn't realize this, but there were two unsupported things being exercised here. One of them was new line support, and the other one was putting a parenthesis in as like a separator without putting some white space in between. So for the purposes of clarity, I think what I'm going to do is do this twice and have one here that is just exercising the new line stuff, and another that's exercising the, you know, using an opening parenthesis to terminate at an atom. So that's still all passing. So my hypothesis here is that if I take just this test, and then just this change, oh no, so for this one it needs to be adding in a new line but not an opening parenthesis. So this is a subset of the changes that I made. So this is, it's all space separated, but with new lines, and with support for new lines in skip whitespace and in parse atom. So I think if I stash everything apart from that, so now I've effectively deleted the stuff that's to do with the stuff that wasn't in that change. Hopefully it'll still work. Yeah, it does. So now that's the thing that I can commit. That's like add support for new lines. All right, and now, why is that giving me a merge conflict? That seems a bit rude. Well, can I just do get restore theirs? I think so. Okay. Okay. Fine. So now this is add support for, what's it say? Tokens delimited by parentheses, because that's, I'm just using the language from the actual test there. Okay, so that worked fine. Oh, crap. I've just realized that it's possible that all of the tests that I've written are wrong, because I even talked about this before. These scripts are a sequence of commands, 0 or more commands. So right now I've been treating like this as the whole string that we're reading. So either as a solitary atom or a single list. But actually, excuse me, in general, these files are multiple lists. So effectively, there's a sort of an implicit top level list. Sorry, I'm going to have to drink some water. Okay. Well, I need to be able to support that. You know, what I was going to do next was sort of like, well, can I paste in these first two? Well, okay, just park that for a second. I'll see if I can parse a slightly different thing here. I mean, I guess if I find that I can parse all of these individually, let's just do one more. Let's just do one more. Sorry, I'm being indecisive. So what's the difference here? Oh, this is checking that you can delimit tokens with a closing bracket. So this one was checking that an opening bracket delimits them. This was checking that a closing bracket does. So what does this look like? Module, then func, and then a single item list with a NOP, and then another NOP here. I think that's just going to work. I'm expecting that to just work. Yeah, okay. I'll just say add another example of parenthesis delimiters. All right, well, I guess I should bite the bullet and make it possible to do something like this. Because at the moment, I don't think we can parse this. And in fact, like I said, all of these tests are sort of wrong because they all need to be need to be inside an array. So let me show you what I mean. I think just temporarily, I'm gonna put a single example at the top here. I think that I should be able to parse something like this, right? And what that should look like is this. Because that's what... I mean, you know, you could argue that this isn't really an S expression anymore. And maybe I shouldn't have called this S expression parser. Maybe I should have called this script parser. It's not, in fact, maybe I could rename it to be script parser, but yeah, maybe that's more sensible actually. But in any case, never mind what it's called. We just need to be able to support this. We need to be able to support, there's a top level list and it contains, you know, even if there's only one thing. So really this, for example, this test here should have been this. You know, there's a list of top level things, but there's only one of them and it is the string hello. But this is what I really care about. So I'm going to try and make that work. What am I expecting? Here, I am expecting it to say it can't read the end of the string because I think all of this is going to be left over when it's finished parsing an S expression. And there's going to be some junk on the end of the string, which is actually another S expression, but I think it's going to complain about that. Yeah, couldn't match end of string in everything after that first one. So I think that's easy enough to fix. Essentially what that means is that here where I'm pulling out a single expression, this should actually be expressions. I've just realized private's in the wrong place. That's annoying. I'll go back and fix that in a minute. Yeah, sorry, I'll do that. I'll do that later. So we need to implement that. But what I'm realizing is that I think we have already implemented that because it's this. Like this is the thing that reads multiple expressions, right? So this effectively is read the inside of a list. And that's this chunk of code here. So I'm going to essentially this whole thing. So I think that is parse expressions, and then now I need to fix up the violence I've done here. Like that. And then I think that's it. Poo. Why has that not worked? Couldn't match white space in empty string. I don't understand why that's happened. going to look at the chat in case someone's telling me why that's happened. Does read handle empty string okay? I'm not sure I understand what's gone wrong here. Oh. Okay. Yes, I think I do understand what's gone wrong, which is that this loop termination condition is now insufficient because previously it was, like I said, we were reading the contents of a list. So the thing that terminated the list was a closing parenthesis, but that is now no longer true because this top level list is terminated not by a closing parenthesis, but by the end of the input. So, So I'm just thinking, is it safe? I think it probably is fine for me to say. I'm just trying to think when this could go wrong. Is it okay for us to read the end of the input there? Like, not really, because we might have started by reading an opening parenthesis. So this feels a little bit risky, but not super risky. I think I'm gonna go with this for now because I think that's gonna fix it. I think that's gonna fix the problem. Yeah, it does. I'm a little bit uncomfortable with that because I hadn't really anticipated this like top level list situation. Of course, there's no real reason that I have to reuse this code. Like, I'm making this loop do double duty. I'm making it sort of work when it's inside an array and also make it work at the top level, and that's what these two cases are. So if this was ever problematic, instead of using parse expressions up here, I could have like parse top level or something. Or I could even parameterize this on the thing that terminates it. Yeah. That's pretty tempting, actually. Because whenever this is being parsed from inside parse expression, we know that it's the closing parenthesis that we want to terminate it. All right, well, I've got the test parsing. Nadia, I saw that you said that you didn't know what I was building. I'm trying to build a WebAssembly interpreter, but at this stage, what that has degenerated into is just building a parser for a WebAssembly source. So that's maybe not, it's not the most interesting thing, but it's the first thing. So I'm just getting on with it. And yeah, Chris, you make a good point. That occurred to me as well. That we could like synthesize a syntactically valid input by just pasting parentheses around the source. So that's sort of tempting as well. I'm going to commit this, and then I'm going to make I'm going to make a git commit, and then I'm going to psychologically commit. Oh no, of course. Right. Okay. It's worse than that, isn't it? Because I'm in this wonky situation. Like, I wanted to get this example parsing to sort of demonstrate the problem that I was talking about. And I mean, that's a perfectly cromulent test, so I'll stick that down the bottom here. However, I've got a problem with all of these other tests now. Because they should all have like an outer array in them. Oh, I'm just going to do it. Oh, not that one. That one was already there. So I think that's correct now. Yeah, okay, thanks, Vim. All right. So I'm actually gonna, what do I want this to look like? There's a few changes there, actually. Let's take them one at a time. So this one is just extracting, well, in fact, it's not this whole thing, but it's extracting parsed expressions, right? So if I just edit this, so that's adding the definition of parse expressions. And if I get rid of that, so this is what it used to be. Oh, well, I obviously screwed that up. What did I do wrong there? Okay, I won't try to be clever with the end. I will just leave it there. I think that should be okay. Yes. And then, yeah, that's what I was going for. Okay, so that, I think, let's just check. Yeah, I mean, that's nice. So that's just extract parse expressions. And now we can do the rest of it. So the diff here is that, yeah, this is all one change really, is changing it so that we call parse expressions at the top here, and therefore that all of these tests change. So no, I don't want that. I don't want to add a test actually. I just want to pick out these one line changes to the expectations. That's what I want. What? Something's gone wrong there, hasn't it? In the merge. Let me stop that. Okay, so I definitely want all of that. That's all good. Why have I ended up with 2 copies of parse expressions? Oh, of course, because it's actually changed. Good call, Git. Thank you. Wow, that saved me. Okay. Yeah, so actually all of the rest of that is good. I don't want that, but I want all of that. Okay, so update all of those tests. Parse expressions rather than parse expression, and terminate when we hit the end of the input. Let me just check that's working. Yep. Return array of S expressions from, and then I can, I mean, do I even need that test anymore? Yeah, I do. Test multiple S expressions can be parsed at the top level. That is important. All of the rest of the places, it was just a single one at the top level. This was the one that really forced that change. I am going to, while I was doing that, there was a little task in the back of my mind about how I was going to deal with this. I'm going to deal with it by parameterizing this. Terminated by So is that a stupid name? Should I just call it Terminator? Whatever. So this one is terminated by this. And this one is terminated by this. Does that still work? It would if I knew Ruby syntax. Yeah, I think I kind of like that. I'm not totally in love with it, but it feels like it's an improvement. I was definitely uncomfortable before that there was that you could do either. And I think I like this more than the... Do I like this more than the Zeta maneuver? There's something pleasant about just synthesizing a new input that's syntactically what I was already able to parse, but I feel like this is probably the right thing to do. I mean, at some point, I'm going to have to do more parsing than this, right? Like, this is barely a parser. This is just breaking apart the input and emitting the pieces in a tree. I mean, I guess that is what a parser does, but you know what I mean? It's not doing any kind of grammatical analysis. It's not categorizing any of these atoms. It just knows what the lexical grammar of atoms is. It doesn't know whether they're keywords or numbers or anything like that. So I think at some point I'm going to have to either modify this parser to do more work, or the output of this parser is going to be the input into another one that actually does more work. And the reason I'm saying all of that is just so that I can punt into the future the problem of dealing with this. But I think what I'm saying is it feels like there probably are separate productions. Well, there are here. You know, a script is 0 or more commands. A command is a module or an action or an assertion or whatever. So I sort of feel like preserving the difference between what can a module look like and what can a script look like that's kind of represented in this code a little bit now. And I think if I sweep it under the rug by actually synthesizing the parens around it, that's a little bit, in a way, that's hiding the problem. Whereas now the problem is sort of explicit, because you have to, it's not always the case that expressions inside an array are terminated by a closed bracket. It's like, oh, that's interesting. Why is that? And like, you can see why that is, sort of. So I think I like it this way. Still works, right? Yeah. Let's say always tell parse expressions when to stop parsing expressions. I think that needs a bit more of a message. The previous code worked fine for the examples we have so far, but it would have allowed the end of the input to always do the same job as a close parenthesis, which isn't what we want, strictly speaking. By explicitly providing the pattern which terminates the list of expressions, we can always be completely clear whether we're expecting the list to be ended by a parenthesis, i.e. any actual S expression list, or the end of the input, i.e. the top level list of commands in a script. Okay, that should be enough for me to remember what the heck is going on there. Okay, so we're getting somewhere. It's nearly time to think about comments. Maybe it is time to think about comments. Yeah, let's think about comments. Why not? We've been good. All right. So, in fact, if I'm taking just this chunk at the beginning, I've already got the expected for that, haven't I? It's this one. So let's do that, except at the beginning, stick in this comment. Tokens can be delimited by parentheses. And then what was it? 2 new lines. Okay. All right. Well, I'm expecting this to fail right off. But how am I expecting it to fail? What's this going to do? Oh, I know what it's going to do. We're just going to get a load of atoms. So each of those space separated sequences of characters are just going to be, including this one, those 2 semicolons, are just going to be read as a completely valid atom. So we're just going to get 1, 2, 3, 4, 5, 6, 7, and then 8 top level expressions, the first 7 of which are the comment. Yeah, okay. I called it. Right, so that's not what we want at all, is it? My immediate temptation is to change skip whitespace to skip whitespace and comments, because it feels like this is probably called at the right place. Is that true? Yeah. We call past expressions, and then immediately, like what I'm sense checking is like, does this get called? Are we going to skip this immediately? But the answer is yes. It's actually the very first thing we try to do is we store the string, we call parse expressions, and then first time around the loop, we skip whitespace and comments. And I think that's sort of all we'll ever want to do. I think looking at this, is that true? Yeah, I think it is. I think that's the only time we're actually ever going to need to do this, and same with whitespace. I think. Because you can only ever, especially because this is the top level, you can only ever be inside an array of things. And the only thing that you can be inside an array is you can be an atom, you can be a nested list, or you can be a whitespace, or you can be a comment. And this thing is proactively stripping whitespace and comments before it tries to read an expression from inside a list. So I think that's right. So now we just need to make this skip comments. I mean, I think I can do this. Else if can read 2 semicolons? Does that seem right? Well, what's the thing that I'm going to... Because down here, like this... Oh my god, what am I doing? Why am I writing this here? I've lost my mind. That's completely the wrong place. Sorry. I thought I was in skip whitespace and comments. I'm sorry, anyone who thought that I was doing some kind of incredibly clever maneuver. I wasn't. I had just become extremely confused. Okay, this is what I was thinking about. Inside skip whitespace and comments. Why on earth did I go? I'm not sure why I made that mistake, but whatever. Okay. Yes, my point was that this is just repeating the same regular expression, and I think that's rather nice. So what do I actually want to do inside here? Well, I want to skip semicolons. Let's just pay lip service to the idea of actually reading this grammar. I've just noticed it's actually right here. Oh no, you can have nested comments. Comments of the latter form nest properly, so you can see this what I thought was just going to be I thought this was going to be a straightforward production, but it's actually recursive. You can see that comments can contain other comments. I don't think we've got any of those in this file. No. Well, then that's definitely not my problem. Anyway, these are single line comments, right? So you have to read 2 semicolons and then 0 or more characters and then an end of line. So I can literally write that. Do I want to put a new line in? No, see the problem there, I know I'm inventing problems that don't exist, is that there won't be a new line if we're at the end of the string. And I could look for either of those things like that, but I think it's easier to just use $, because that is what $, means. It means the end of the line, and if it's the end of the string, then that will also be the end of the line. So I think that's what I want. So I'll just make this the same. So if you can read 2 semicolons and then up to the end of the line, then do so. And this pattern's a little strange, but it's working fine right now. Just checking not to say anything. Oh, well, Nadia has left. I'm too late to say goodbye. All right, so couldn't match in. Oh, interesting. I hadn't thought of this. So you can see here that what's happened is that it has successfully skipped the comment. Now we're sort of at the end of the comment. Oh, right. Right. Okay. So this, I think this is fine actually, because this problem exists anyway, but this matches the sort of 0 width. This, you are at the end of the line, but this doesn't actually include the new line. So this is reading everything up until the end of the line. This doesn't actually read the new line, but that's not the problem that we're having. The problem we're having is having slurped up the comment and thrown it away. Now the next thing in the input is some more white space, which of course is always going to be, well, I mean, especially with this, the way I've implemented it, there's always going to be some white space after a single line comment, because I'm not even slurping up the new line that may or may not be there. So what we need to do actually is do this over and over again, because we don't know how many times, like up until now, it's been, there's only been a single category of thing that we're stripping. You know, we're only skipping white space. So as long as we've skipped white space, then by definition, if we've skipped all of the white space, then there can't be more white space to skip. But now we can have interleaved white space comment, white space comment, white space comment, and so on. So what we need to do is sit in a loop here, try to skip white space, try to skip a comment, and if we haven't done either of those, then we can stop. And then I think that's going to do the trick. Okay, that's done the trick. Okay, I think I'm just going to say add support for 1-line comments. And I'll just say now skip white space. Needs a loop inside it so that we can alternate between skipping white space, and skipping comments where the two are interleaved. Okay. I mean, I think we've got enough. Now that I know that we can successfully parse the beginning of this, I'm tempted to actually put my foot to the floor and try parsing this and see what the output looks like. Because A, can we slurp in this whole file without raising any exceptions? Like, can the parser get through this without getting hopelessly confused? And B, is the output of that what we actually want it to be? So I must have that in my history. Yeah, let's have a look. Okay, well, the good news is it succeeded. I don't know why I'm saying that as if there's bad news. This is all good news so far. Let's go back to the... I think this view is a little bit nicer, and if I embiggen slightly, we can... I think I need to do a little bit of a side-by-side comparison here of, like, is this what I expected to see? So you can see module func, not, module func, module func, not, module func, not, module func, not, that's all right. Module func $f not. Now, I mean, I don't know exactly how this is supposed to be parsed, but because this is in the tokens can be delimited by parentheses section, I don't think this is anything special. I think it's correct that that's been parsed as a single atom. This also looks correct. Module table 1 funcref func lm blah blah blah. I32 const 0 0. Yeah, that all looks like it's parsed correctly. What's this? Data. What? Oops. It's not letting me move that window off the screen. Memory 1. Data I32 const A. Yeah, I'm a little bit nervous about this. We don't know about strings, but it's worked fine. You know, the atom includes the opening and closing quote, but I think that's actually what we want. So that seems fine. Import spec test print func. That's all okay. Tokens can be delimited by comments. Oh, I'm not so confident that we've done that. Module func blah. Yeah, that's not right. So this is a comment and it shouldn't be included. Okay. Well, that sucks. We're going to have to support this. Let's do that. So again, I'm just going to manually reconstruct that here. I just think it's easier for me to deal with these when they're all the same number of lines. That's why I'm going to the trouble of reformatting this, is just so that I can have all this input on one line. So this should look like module... I think it's just module func, right? Yeah, this is just a comment. Okay, so hopefully now when I run that without the input, yeah, okay. So this has all become coalesced into a single item. So the thought that immediately occurs is there's an easy way to prevent this, which is just to say that atoms can't contain semicolons, because then we will read up until the semicolon and then stop, and then this should be eaten by skip white space and comment. So it would be very convenient if that were the case. But can they, essentially? Because if they can, then that's not... it's not impossible, but it's going to be a little bit more difficult to support. So I'm just scanning through here to see if there's anything about what these S expressions can look like. Just clicking on this link to see what semantics.md says. No, it tells you to look at the documentation. Okay. Let's just have a quick look at the spec, because there is this text format section in the spec that says things, that's got this lexical format that says the character stream in this. So sorry, I got ahead of myself. So this is the section of the spec that just talks about, you know, these two file formats, the binary format and the text format, because all the rest of it can talk about the language sort of in the abstract without worrying about how programs get serialized as a sequence of bytes. Whereas this binary format and text format sections of the spec are saying, like, here is how you write down a WebAssembly program as binary or as plain text. And so that's why I've gone through to this to try and see if there was something, and I've immediately gravitated to lexical format because that means what is the syntax of tokens, like what can tokens look like, and that's what I'm trying to figure out right now. So indeed, here is the section that says tokens. The character stream in the source text is divided from left to right into a sequence of tokens defined by the following grammar. Keyword, or I guess these are various flavors of number. String ID brackets reserved. Keyword A to Z. ID jar. So what are IDs? Identifiers can be given in both numeric and symbolic form. Symbolic identifiers are blah, 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 blah. Oh, this is talking about things that start with $. Okay. Okay, that's not what I'm looking for. I was really hoping for something that says, here is what. Yeah, I don't know what I was expecting, really. I was hoping, I mean, this is quite hopeful, for example. This says keywords can only be A to Z. So that's encouraging. What is ID char? Oh, okay, right. No, I should have paid attention to this, because even though an ID is something that starts with $, keywords, what is this? They can start with an alphabetical character and then be followed by an ID char, 0 or more. Anyway, these ID chars are alphanumeric, exclamation mark, octothorpe, $, that's colon. So I think this is good news. I mean, I haven't been very rigorous here, but this suggests to me, yeah, any sequence of printable ASCII characters that does not contain a space, quotation mark, comma, semicolon, or bracket. So we have dealt with brackets and spaces. We haven't dealt with quotation marks, commas, and semicolons. I mean, I don't know what a semicolon might mean, but it definitely can't be part of, or I don't know why I'm saying definitely. This suggests to me that it is unlikely that it's legitimate to put a semicolon inside one of these individual tokens. So for now, I'm going to take that as permission to do the easy thing, which is just to adjust this to say you also can't contain a semicolon. And I think that's going to fix this. Yeah. So yeah, all we needed to do was prevent the parser from running past these letters. So it stopped there and made a single atom. And then this has just been skipped over by skip white space and comments. So it was actually a very easy change. You know, it was literally a 1 character change, but maybe one of the longest winded justifications I've had for making such a change. In fact, I can see, this is something that I can put in the commit message. So what is this? I already wrote a commit message about, okay, add support for tokens delimited by comments. Yes. And now I can say the lexical syntax described in the spec strongly suggests that we shouldn't expect to see single semicolons, i.e. not the start of comments, inside tokens. So it's likely safe to forbid them from the syntax of atoms in our S expressions. Fine. Okay, so in that case, let's bounce back to this. How far did we get? So I think it was here. This module func nop, func $f, func br0. Yeah, I mean, I don't care that this was a 0. Data A. Yeah, so that seems to have worked. Space required between symbols and non-parenthesis tokens. Module func block $L, I32 const 0, br table 0 $L. So the problem here, I guess, is that these are now about these, like, these are sort of, the purpose of having these here is to show this is the right way of doing it, and then this is an error. So this is saying a space required between symbols and non-parenthesis tokens. So the fact that there isn't a space here means that this string is supposed to be malformed. I think I'm just going to ignore these for now, and because I'm not actually evaluating any of this yet, so that there's a temptation to say, like, oh, if I could yank this out and make sure that this was a parsing error, but to be honest, I'm not sure I fully understand what a symbol is. Like, clearly the two tokens that are participating in this example are 0 and $L, but which one of them is a symbol? Arguably it could be either. I would say it's more likely to be the thing with the dollar in front of it. Although that's when we were looking at the spec, it called this an identifier, symbolic identifiers. So yeah, I guess the $L is probably the symbol. And it looks like there are some grammatical rules about what can appear inside a... Oh yeah. Oh, interesting. Okay. Yeah. Sorry, I'm just reading this as I talk. So I can see here, this is giving the error unknown operator, because this is like a number that's... Yeah, I mean, I'm not sure exactly what the problem is there. But here it's saying unknown label, because this is being parsed as a valid label, L0 with a $, in front of it. But you can see here, I assume that this is that this $L here actually refers to this $L here. So this is a label for this block. And during analysis, you would see that this label is invalid because it doesn't exist in this program. So this feels like a much higher level problem than I'm trying to deal with at the moment. So I think I'm just going to skip past these. And I mean, it'd be... I wonder what this is supposed to parse as. Oh, it looks like it's supposed to parse as a single thing. Oh, hold on. Something interesting is happening, though. I was so concerned with the meaning of all of this that I didn't notice that we're not even correctly parsing this, because this, you can see, is parsing as there's a quote character, and then it's actually parsing the contents of this string. You can see it's broken out an individual quote atom, and then it's tried to parse the contents of that string, which is actually not correct. In fact, this parsing this is clearly supposed to fail, or, parsing and validating and whatever else. So that's wrong, actually. Because this quote is just being treated as any other atom, but actually it's not, it's special. So we're going to need some support for this. Let's write a test. So it's going to be something like okay, I'm going to leave new lines out of it so that I can have a single quoted. No, I'll just do it like this. Because I don't want to get all confused about quotes, is the point. Well, I mean, the most basic thing I want to be able to parse is that. And I want that to look like that. So this is getting a little bit meta, but I mean, I should commit to a quoting style here, shouldn't I? Let's just do this. Okay, I think this is ultimately less confusing, especially if you're not familiar with that style of quoting. So yeah, maybe this is the. I'm sort of thinking as I go here, but I think maybe this is the thing to do. Is like, once you hit an open quote, you just slurp up everything. Until you hit a closing quote. So even if it's, I was tempted to put a new line in there, but I actually don't know whether these strings can have new lines in them, and it would get a bit syntactically gnarly, because then I really would have to do %q around this. Let's just leave it like this for now, but I think hopefully this makes the point that, maybe it makes the point even better if I do something like this. Yeah, maybe that's, let's make this a bit, I'm stuck for what to type here. Comment. Okay, so the point is that if we hit an open quote, then we just slurp everything in uncritically without trying to interpret it at all until we hit another quote. And then that whole thing becomes that atom. And yeah, I think I'm making a design decision here to leave the quotes in, because otherwise the atom has kind of lost information about what it looked like in the source. Here the fact that all of the raw things come out as just unquoted strings. So when you see raw module in the source, you get a string containing module. We have to somehow differentiate something that was a bare string and something that was a quoted string. There's a temptation to start sort of building a richer data type than I'm just using native Ruby arrays and strings here for this as expression. But I think for now, what I'm going to do is just basically preserve the input verbatim, including the opening and closing quotes. And so then at least we haven't thrown away the information that it was a quoted string. We could be doing more with it than we are, but I think that's a decent start. So yes, it's not working right because it's trying to. Oh yeah, it's interesting that it does successfully parse this, right? So the way it's trying to parse this is there's a top level atom that looks like a quote, and then there's this nested list with hello world in it, and then this comment just disappears and is treated as a comment, and the comment includes this closing quote. So it's syntactically valid as far as the parser is concerned, but unfortunately it is not the right shape of S expression that we were looking for, because our parser doesn't know about quotes. So I think we're gonna need another case along the lines of this, where it's like, here is the place where we sort of branch, where we switch on like what's the next thing that we're looking at effectively, what's the next token, even though we haven't done the tokenization yet. So I think it's okay here to say else if can read, is that right? I think that'll work okay. Let's just say parse string. So what's this going to do? It's a little bit like this. In fact, there's a temptation to extract this out into its own function now, but I'll resist that. So it's not a million miles away from this, right? So how is it different? Well, firstly, we only read quote unquote. Secondly, we don't read expressions. We're just going to read, I guess, the contents of the string. And we don't have to, there's no recursion here. We're not recursively parsing anything. I don't think there's string interpolation in this source format. I hope not. So yeah, instead of that, we can say read. And then what are we reading? I think we're reading anything that's not a quote. I think we're reading 0 or more non-quote characters. So this could be the empty string, in which case this string is going to be the empty string. So I think that's right. Oh, right, yes. So that is correct, but I forgot. I'm just throwing away these delimiting quotes where I just got done saying that I wanted to keep them. So having laboriously justified that, I better actually do it. How do I want to do this? So here... Okay, thinking out loud. I always want to, when I need to do something new, I always kind of want to try and find a way to do it that is similar to how I've done it somewhere else. And this is actually, although this is a different shape of problem, or rather, it's a different underlying problem, but it's the same shape of problem as what we're doing in parse expressions. I think I'm going to try and do a similar thing to what we're doing here. And what I mean by that is here we initialize this empty result and then we mutate it and then we return the result at the end there. So I think what I'm going to do I want to do this? I don't really need to do this. Yeah, I am going to do it. I'm not sure that this is a good idea. I'm not sure. Oh well. I mean, mainly the reason I'm not sure is because I don't really like mutating things when you don't need to, and I'm thinking like, oh, I could just join. I could put these 3 things in an array and join them and so on. But I think, like I said, this is sort of has the same shape of what I'm doing up here with parse expressions. And furthermore, this makes it really obvious what the order of evaluation is as well. I'm sort of worried that if I put these three expressions into an array and join them, because read has a very important side effect, it maybe obfuscates the fact that these have to run in this specific order. Whereas if you write the code like this, it sort of makes it really obvious. Yeah. Well, let's see if it works first before I wring my hands too much. Oh, there's an operator precedence problem. Well, that's enough to turn me off this whole thing. Okay, try this instead. Is that bad? I just finished saying that I could have just joined them. Let's just see if we can make the test pass, and then I can. Okay, all right, the tests are passing. So is that more or less grotty than this? Oh, that has the same problem. Right. Yeah, okay. I mean, obviously I can just put parentheses around my method arguments, but well, I think this one's going to win. I'm sorry. Just reading the comments. Well, yeah, I just seen the comment about shouldn't be possible to have semicolon in kind of inside a string. I don't see why not. I don't see why not. I think you should be able to do that. I think once you're inside a string, you're in a new language. You're in a different language, the language of the contents of strings. So if it did have string interpolation, then whatever the string interpolation syntax would become meaningful. But apart from that, I don't think there's any meaning inside a string, including comments. So oh, okay, right. Fine. All right. Okay, I'll shut up then. Okay, I'm just going to stick with this. I'm going to say that this is okay. Primarily because it's the only variant of it I've written that actually works. And yeah, I could write this different ways. If I started putting parentheses around my read arguments, I don't know why I'm calling read without parentheses in the first place. I think it's because the argument has got curly braces. It sort of feels like I've got enough brackety things syntactically there. So I'm going to go with this. Let's see. So yeah, I'm just going to convince myself that it's okay to have comments in there. Okay, so this is basically, what is this? Add support for string literals, I guess. How does Git work? Is there anything interesting to say about this? I don't think there is really. Oh, there is. I've decided to leave, i.e. reinsert at great expense the quotes around the string, because otherwise there's no way to distinguish a bare, an unquoted token from a quoted string. Arguably, we should be using the information available at this point to distinguish the values, e.g. make a token string instance, but I'm not going to do that right now because I don't need to. Okay. All right, so let's bounce back. So now it feels like I'm, like what I wanted this to feel like was when you're doing real professional, serious acceptance test driven development where you're bouncing back and forth from failures in the acceptance test to failures in the unit test and then back to the acceptance test. And like for the first 90 minutes of me working on this, I wasn't really able to do that, but it feels like it is actually happening a bit now. So that assert malformed, that where I had the problem before, module quote, and then this whole string including func, that now seems to have been parsed correctly. So that's good. I can see other strings down here, unknown label. So yeah, where previously this was broken up into the opening quote and then the word unknown and then the word label and then the closing quote, now those have all been chunked together, so that's good. Oh, this doesn't look very good, does it? I don't like the look of that. What's causing that problem? How far have we got? Sorry, it's a bit hard to match these up. This is module func block, assert malformed, 3, 4. Okay, so it's the fourth one. 1, 2, 3. Oh, it's all the way down here. Oh, look, our friend the escaped quote. Okay, this is the perfect example of what I was talking about with the language of strings. Okay, space required between strings and non-parenthesis tokens. All right, well, clearly this is trying to make some kind of point. But the actual problem it's causing me is that I am treating that as being a string. So you can see here, data. Oh, sorry, that's that one here. Oh, it's really hard to read this because it's been pretty printed, but you can see that we've got a string that contains the characters open bracket DATA backslash, and then there's the closing quote, and then there's a separate atom containing a, then a backslash, and then a quote. That's messed up. Okay, there are a couple of things messed up there. I mean, one of them is that we're not correctly supporting escaped quotes, but this is actually a separate problem where this identifier has just run on into the backslash and the quote, which is not good. Okay, so how are we going to deal with this? Oh, actually, I think both of these things get solved. Yeah, I was tempted to start trying to solve this problem, but then I realized that we already have... You're not allowed to put... Like, this whole section is about you have to put a space between a string and a non-parenthesis token. So this whole example is about how you have to have spaces that separate quotes. So maybe I don't need to worry about that too much. I still need to be able to handle it more gracefully than I am at the moment. But actually right now, the only problem I need to solve is that quote escaping doesn't work. So let's do that. So yeah, now down to the unit test. What do I want this to look like? I think I want it to look like hello escaped quote world. Now this is where things get a little bit terrifying, because we're inside Ruby, which has its own rules about what things in strings look like. But because we're in a single quoted string here, do I believe what I'm saying? What I wanted to say was that backslash doesn't have any special meaning, but I'm actually a little bit... I just want to double check it. I'm almost certain. Yeah, okay. So you can see that this has been preserved. And even though when it's inspected, the backslash gets escaped with a backslash. So I suppose... Oh, it's because this is printed as being double quoted. So I don't think... Oh, no. I was going to say, I don't think a backslash is ever meaningful inside single quoted strings, but look, it is if it's a double backslash. Anyway, sorry, that's not the point. It works fine for for an escaped quote. Why on earth is this the case? I do not like that. Anyway, doesn't matter. This works fine. So, hello world. That's what I should get. And I believe that is not what I get. So many levels of escaping here. What's this telling me? Backslash, quote, hello. 6 backslashes, 2 quotes. Okay, I think this is 1 backslash, 2 backslash, 3 backslash. Oh, I can't even read that. This one's okay. This is world followed by a backslash and a quote. So yeah, this has all gone wrong. This first one is parsed as a string, so we've wrapped quotes around what we managed to read. In fact, these are this and this are the quotes that we wrapped around it. Yeah, and that's the backslash. Okay, all right. It's very hard to read this when it's been double escaped. Yeah, so anyway, the problem is that we're this quote here is terminating the string, right? And it shouldn't be. So so now we need to account for so at the moment this is saying read 0 or more of character that isn't a quote. But what we want to say is read 0 or more of character that, well, we're not allowed to read the best way to do this? I think the best way to do it is to give it the opportunity to read an escaped quote. So I think that looks like, yeah, I think we could just say an escape quote looks like this. So we're saying read backslash quote, like that's a legitimate thing that you can read inside a string. It doesn't have any special meaning. You can read the 2-character sequence backslash quote, or you can read any character that isn't a quote. So I think that's right. I think this is saying 0 or more of, you can read as many escaped quotes as you like, and you can read as many characters that aren't quotes as you like. this won't allow it to read an unescaped quote. It can only read the only way it can read a quote character is if it also reads a backslash immediately before it. So I think that's right. I think that's going to fix it. But it took me a second to... Yeah, okay. So... add support for escaped quotes inside string literals. Okay. I think that's right, though. And I can't think of anything insightful to put inside that commit message. So where was that? Yeah, here we are. Data. So now that whole thing is all in a single string. Data LA, data LA. Yeah, I mean, like I said, all of these things that are looking for unknown operator and bad labels and things, we're not in the business of implementing assert malformed yet, so I'm going to ignore the fact that some of these things that are supposed to be malformed are probably not malformed according to our parser. As long as we can, I'm just trying to get to the point where we can read in one of these files and have it in a structured form so that we can try to interpret it. This is looking pretty hopeful, actually. These all look, despite containing all kinds of, you can see there's, I mean, GitHub isn't even trying to render these characters. If I look at it raw, does Chrome try to render them? No. Okay. Well, I don't know what these Unicode characters are. Well, maybe they're just, maybe they are just, you know, nonsense placeholder characters. But Ruby doesn't care. It seems to have slurped them up just fine. So that's good. I'm just eyeballing this for anything unusual looking. But I can't see anything unusual looking. So, okay. Well, I think we're done. Well, just to clarify, I think we're done with implementing this. I think we're done with implementing this parser. This seems to deal with all of the cases that we need to deal with, at least in this file. So just to finish it off, and hopefully not actually do any more programming right now. Let's try looking at this int literals, because this is what I really want to parse. That tokens was just something simple, although arguably this file might be easier to parse than that one because it's not going to test all the edge cases. But I wanted something that was relatively, that was going to make sure we were doing the right thing. So this all looks good. There's a top level module containing all these func definitions. You can see that when we interpret this, we're going to have to deal with like stripping the quotes off from these strings, but such is life. Yeah, this all looks great. I think this is what we wanted. So the only decision I'm making now is, do I want to make a start on interpreting this? Or do I want to call it a night and come back to this next time? I guess I'm really tempted to have a go at this because it feels like that's the payoff, but maybe that's a nice cliffhanger to leave it on, is to have, I mean, I realize that this is, there's been some false advertising here where I said I was going to work on WebAssembly and I haven't really. But look, we're ready. We're ready to implement an interpreter for WebAssembly. So, you know, we're nearly there. I think this has been okay. I think I am going to do this again. I didn't know how nervous I was going to be programming with people watching, but actually this was basically fine. It feels a little strange to be sitting here talking to myself. It's like pairing with someone, but without anyone here. But that was enjoyable enough. I think I could do this at least once more. And I mean, I reckon now that we've got a parser, I reckon that this is not going to be that hard to implement. I mean, we're going to have to do a bit of work to parse these, and I'm a little bit nervous about the signed numbers, and the add here is we're going to have to deal with. But more or less, I think this is going to be fairly easy to do. So let's leave that as like the carrot for next time. Thanks very much for tuning in for this stream. I hope you enjoyed it. I'm sorry it was a little bit chaotic and strange, but you know, that's kind of hopefully that's what you expected. And yeah, please join me next time where I'm gonna have a look at actually executing that int literals test. That's at the very least going to make me implement numbers, and then maybe we can move on to implementing some of the operations on integers, and then maybe we can move on to floating point numbers, and then we can start looking at, I don't know, control flow or memory or some other thing. So that's exciting, isn't it? Wow. Okay, well, have a great weekend, and I will see you next time. Goodbye.